Hey, what's up guys? So I'm going to show you how to do this integration question, which is a definite integrals question using U-substitution. So definite integral meaning just these values up here, so the upper and lower limit. Okay, so we're going to use this u equals to 1 plus x substitution. So the first thing we're going to do is just differentiate this guy over here. We should just get 1. And so du equals to dx. Nice and simple. One additional thing we need to do is these ones over here, these upper limits, they're in terms of x. So if I want to change to du, then that means I need to use u values, right? So we're going to use this over here. So let's say when x equals to 0, u equals to 1, right? Because it's just 1 plus 0. When x equals to -1, u equals to 1 plus -1, which is 0. Okay, so when we come over here and write the integral again, we're going to replace the top with 1 and the bottom with 0. Okay, now one last thing is, let's get a new color. U equals to 1 plus x. That means we can say x equals to u minus 1, right? And we're going to need this because we're going to sub this one with this x. Okay, and we will sub this one inside here with that u. Okay, so this is what it will look like. U minus 1 and u to the power of 10 and du. Cool, so now everything is in terms of u. So let's just let's just expand this out. 1, 0, u to the power of 11 minus u to the power of 10 and differentiate in terms of u. And now when you get to this step, so hopefully you remember how to do definite integrals. Put square brackets and we're going to put the upper and lower limit, and now we're going to evaluate it. So if you see a question that has any definite integrals, you should finish off with some sort of value. So 1 over 12 minus 1 over 11 minus, if you sub 0 in there, we should get 0. What's this one here? So -1 on 1, 3, 2 is the answer. Okay, so just one little extra step involving u substitution. Let's go through one last question before we wrap this video up. Okay, and just try it out with another example. So let's differentiate this guy. Actually, before I differentiate, I should actually change to index form so that I can differentiate. And let's multiply our dx to the other side. I'm going to change this form a little bit and say 1 over 2 square root x minus 2 dx. Okay, hopefully that made sense. Over here, let's change our limits. So when x equals to 18, u equals to square root 16, which becomes 4. When x equals to 3, u equals to 1. Now, I think that's pretty much it. So we'll just have a go at putting these values in. So the limit is going to be the limit is 4 to 1 now, right? So 4, 1. X, we actually don't have anything to substitute it in. So I'm going to bring this over here and let's square everything. So we have u squared is equal to x minus 2, which means x equals to u squared plus 2. Right? So over here, let's say u squared plus 2. This one is just u on the bottom. And for d, oh, actually, we shouldn't do that because we have this. We already have this bit and dx, and we've got the dx here as well. The only thing missing is this 2, right? So let's actually write this again and say 2 du. You know what? This guy just come over here. 2 du is equal to that. So that means we can just sub 2 du in. So times 2 du. And let's just say 1. So 4 to 1, u squared plus 2 du, u cubed on 3 plus 2u, 4 to 1, and let's just sub the values in. So 4 cubed on 3 plus 2 times 4 minus 1 cubed on 3 plus 2 times 1. Okay, so I don't know what the answer to that is. So let's bring out our calculator. And we should have 54 is the answer. So if you guys have any questions on that, just leave a comment below. But other than that, that's how we use substitution to evaluate definite integrals. Sweet, so I'll catch you guys in the next one.